Okay, so now we're going to do an example that is a little harder because it involves those properties of E. So again, we know that we're going to have to use the separation of variables technique because there are x's and y's together. And this time we also have an initial condition, so we're also going to have to solve not just for the general solution, but be able to apply that initial condition and figure out what C is. So I started by saying that y prime is dy dx, that part's fine. And when I see fractions in an equal sign, usually my gut reaction there is to cross multiply. So you may do that, but then you'd quickly realize that that is not actually going to separate your variables. So you'd almost have to think of it, I mean, you can do that and then rearrange, but what I would do first is I would probably rewrite it so that it was this and then this to the -2. Bringing that up, now I multiply both sides by dx, so then I get dy equals, so if you multiply by dx and then also divide by this at the same time, you're going to get those together, and then you're going to have x to the -2 dx. So in this step, I multiplied both sides by dx, and I also divided both sides by y plus 3 to get that over there. And so again, with a little clever rewriting, so you're going to have the, this is the same thing as 1 over y plus 3 dy equals x to the -2 dx. Okay, so once you get to there, you're like, all right, I'm ready to integrate both sides. So integrate both sides, and then you're integrating 1 over, y plus 3. So this would actually be a u substitution, but because the derivative of y plus 3 is just a 1, you kind of get away with, you don't really have to do the full u substitution. You know that that's going to end up to be ln of y plus 3. So, do I have room for that over there? Okay, so I'll just write it up here. Okay, so I'm going to say when you integrate 1 over the stuff, it's ln of the stuff, right? So we're going to have that. And again, I know that there's a plus c there. And then I'm also going to integrate this side. So I add 1 to the exponent, so that'll make that a -1. Divide by that number, just puts a negative out front. And that is going to be a plus c over there. Okay, so once you get to there, you can raise both sides to the e, because you're trying to get y by itself. So the only way you're going to undo that, right, is to e both sides. So we do this. So ln and e kill each other, and technically that's absolute value, but when you do this step, it kind of drops that absolute value. So you're going to get y plus 3 equals. So then you've got kind of this mess here. You're like e to all this junk. Well, one of the properties of logs and exponents is that if you have two things of the same base, you can add the exponents. For example, if I had asked you previously, just before this problem, I'm just going to do this off to the side. If I said, what's x cubed times x to the 4th, okay, you'd say, okay, like bases, you add the exponents. So this is the same thing as x to the 3 plus 4, aka x to the 7th. Okay, we're going to kind of use this property in reverse. So now I'm going to tell you that I want to rewrite this. See how it's like this? 3 plus 4. This is my 3 plus 4. So it's e to the 3 plus 4, whatever plus whatever. I want to go backwards and write it as a product. So how am I going to do that? I'm going to write it as e to the -x to the -1 times e to the c. And again, if you kind of apply this, you're like, okay, like bases, add the exponents, it would take me back. So I didn't do anything there that was mathematically incorrect. And I think it's sometimes easier to just kind of view it as something you already know. So we're going to kind of think of it like that. And then I got to get rid of this. And then, okay, so now what we can do is, because I have this e to the c, guys, e is a constant. So a constant raised to some other constant, right, is just some other constant. And you're going to do this very frequently in these types of problems. So just know that you can always rewrite this as just some c value. So there's going to be some c, and then it'll be times e. And again, that -1/2 power, if you'd prefer, you can think of it as -1 over x, right, if you want to think of it like that. So you've got that, and you want to get y by itself, so you could just subtract 3 from both sides. So I'm going to write it as this to the negative 1 over x, and then it is a minus 3 on the outside. So I've solved for y there, and now I'm going to apply my initial condition. So my initial condition is x is 2, y is 1. So I'm going to say, so apply IC for my initial condition. So I'm going to say 1 equals some constant, e to the negative 1 over 2, because my x value is 2, minus 3. And the whole reason we had to kind of go through this is if you tried to apply your initial condition here, you'd get into a lot of trouble because you could plug in, you know, a y and an x value there, but you wouldn't ever be able to figure out that c. That's why we had to go through this process. Okay, so here I'm going to add 3 to both sides. So I get a 4 equals ce to the negative 1/2. Oh, well, darn it. Okay, I'll just write it in 2 steps. Okay, so having e to the negative 1/2 basically means that's in the wrong part of the fraction. So you can think of this as 1 over the square root of e. So you still have c, and then it's times 1 over the square root of e, because the negative 1/2 power means square root, but it's negative, so I got to put it in the denominator. So we've got that, and so once you have that, you can, you know, this is the same thing as 4 equals c over square root of e. And then let's just cross multiply, so you get c equals 4 square root e. Okay, so don't forget to go back. Your final answer should be y equals 4 square root e, okay, because that's my c value, times e to the negative 1 over x minus 3 is my final answer there. Okay, so quite a bit of work to get there, but we were able to get an answer. All right, so hopefully this next one's actually a little easier, a little less work, because I used up all my room anyways. So here you've got x's and y's on the right. So again, that separation of variable technique is going to be handy. I would start off by multiplying both sides by dx. So if you do that, you get dy equals 4x cubed y plus 20x cubed dx. Okay, so you've got that, and now you're like, well, how the heck am I gonna, you know, move that around? Well, you'll notice here, now you've got a GCF on this side. So, because you need to be able to separate them. So I'm going to pull out a 4x cubed, and I think that'll leave me with a y plus 5 dx on that side. Now that I have my y terms together, I can divide both sides by that. So I get dy over y plus 5 equals 4x cubed dx. And now I can do that integration technique. And again, if it helps you to write this side as 1 over y plus 5 dy equals 4x cubed dx, that might be a little bit easier for you. Okay, so I'm going to integrate both sides. I'm integrating this side with respect to y and the other side with respect to. Okay, so once you write it like that, you can integrate. And the integration of 1 over the stuff, as long as the derivative of that stuff is just a 1, you can just say it's going to be ln of y plus 5 equals the integration over here. You're going to have add 1 to the exponent, and then when you divide by 4, that 4 and that 4 kind of kill each other off. And then don't forget your plus c. So we've got that, and our goal here is to get y by itself. So to get this y by itself, we're going to have to e both sides. So you e both sides, and then you're going to use that same property. So the e and the ln are gone, so you've got y plus 5 equals, and you're going to use that same property. So if you need to write it out again, go ahead, times e to the c. And again, e to the c is just a constant, so some of you are going to start skipping that previous step there, and you're going to go right to just saying it's c e raised to the x to the 4th. Okay, so once you've got there, subtract 5 from both sides, so to get y by itself, and so you end up with ce raised to the x to the 4th, and then it'll be a minus 5 because I'm moving that to the other side. From there, you can apply your initial condition. So I'm going to apply my initial condition, So x equals 1 and y equals -3. So I'm going to say -3 equals c e, and since x is 1, it'll be 1 to the 4th, which is just 1, minus 5. Go ahead and add 5 to both sides, so you end up with a 2 equals, well, e to the first is just e, so it equals c times e. Divide both sides by e, so you get 2 divided by e equals c. And so then you're going to go ahead and plug that back in. So your final answer is y equals 2 over e, or you could write it as 2 times e to the -1, either or. And that'll be e x to the 4th minus 5. And that would be your final answer on that one. Okay, so go ahead and you can work through, excuse me, you can work through the rest of the homework. Hopefully that clears up some of those differential equations. Have a great day.